Alright, what's up everybody? So time to get back to our massive refactor, I think, in order to get WebRTC working. And so I didn't get a chance to work on anything yesterday. So this is going to be one of those fun things where we spend a bunch of time conceptualizing like how we should lay all of this out. And then you walk away for a day and then you come back forgetting completely what you were doing. So that's kind of what we're looking at now. I didn't even get a chance to kind of brush up on it this morning because, you know, it's one of those things like when you're going to stream, that's when you're going to have difficulties with your computer. So I've been fighting still. I can't get my GPU encoder to work. No clue what the deal is there. And I was having all kinds of frame rate issues, which is just insane considering the size of this machine. So, problem for another day. Okay, so I think I had like a temp. Is it in here? They were kind of throwing around. Or is it in here? Okay, so this is sort of like, I think, where we were tossing around what the like API might look like. That we might have like a connection manager. I started thinking about it a little bit, was it this morning maybe? About a potential other approach would be maybe that we could take a WebRTC and then wrap it, right? So if we look at here, right, input mod, all of our input types are actually in enum here. There's nothing that says a WebRTC has to be only an input, right? So potentially we could create like its own type here and then wrap it, right? So we could do an input WebRTC and then do like a WebRTC new, right? And maybe from the end of that, we could get like the input side. I don't know. I mean, we really need to kind of understand WebRTC a little bit better, I think, in order to... So maybe, the thought here is maybe we should play with WebRTC a little bit more before we kind of land on what this should look like. Because I'm not fully sure how we're going to do this yet, because we know that WebRTC, we can have multiple people, right? So we end up having like multiple participants, which creates a situation where we have multiple inputs and multiple outputs. Is that how a multi-party is going to work? That's sort of the thought anyway. Because we do have, right, we can have user... Yeah, I guess I don't know. On the WebRTC connection, is each peer sending their own video and screen to the client? That's the part we don't understand yet. Let's close out all of this and let's go take a look at the examples that are here. Oh, that's the front end stuff I started working on. GST examples. There we go. Okay. All right, so here's a multi-party send and receive. I think that this is written... Oh no, it is in Rust. Okay, let's walk through this. Okay. Okay, so we've got an audio mixer and video mixer. So they're kind of already doing something, right? All right, so we have a bin that's representing a peer. And I don't know what this unbounded sender is. My guess is this is what's going like over the signaling WebSocket. All right, and so here's the deref for when it's when it's dropped. So this is all new to me as well. I'm not as familiar with kind of like the upgrading and downgrading. So this looks like we're taking a weak peer and returning back an option peer. Okay, so this is just okay. So when we create the app, we're returning back an app as well as 2 streams. One looks like it's for GStreamer messages. The other one looks like it's messages on the WebSocket for signaling. JT, how's it going? I'm doing pretty good. I'm just trying to I haven't touched this since we ended the stream on Monday. So now I'm like trying to remember what was going on, and I kind of want to play with WebSocket stuff a little bit more to fully understand how we might leverage it before we kind of start switching up the entire design of things. So this looks like it's creating a video test source, encoding it in VP8. This looks like it's creating an RTP payload for VP8. And then splitting that to a queue and then a fake sync, okay? And so we're doing the same thing for the audio. And what is this one? Why do we have 2 audio test sources? So this one we're sending into an audio mixer. And we're muting part of it. All right, we should run this. I kind of want to see what this pipeline's doing. So I suppose this is something we could have done in our design too, right? Where we just create this giant string and we could have asked for things by name, but I kind of like having handles to things. Okay, so here's where we create our pipeline. Here's where we're getting a stream of messages from the bus. Channel for outgoing WebSocket messages from other threads. I think, from my understanding, this is some kind of channel, like the equivalent of a Go channel. And so this would be the send and receive sides of those, okay? Okay, and so we set the pipeline to playing. Okay, so for peer in initial peers. Where did we create the initial peers? Okay, so there's none in there. This is like in the event that we did that. Okay. So we initially set the pipeline to playing, and then we add peers, and then set it to playing again. My guess is to get all of these elements also in a playing state. Okay. And here's our WebSocket messaging. Room peer message. Okay, so what this looks like it's trying to do is over the WebSocket, it looks like this is sending a message directly to a specific peer. Drop peers. messages in JSON format. Okay, and so this is like the ICE messages. Okay. Okay. So this is just like, when does somebody join the room? When does somebody leave the room? Okay. I think I have an understanding of what it's doing. Oh, it's dropping the guard. So that's effectively unlocking it, right? That's like doing an unlock on the mutex. Okay, and so here's messages coming from the pipeline. And I don't think we're too concerned about these. Okay. Okay, so here's sort of the magic. So at the point that the WebSocket receives a room peer message. Wait, no, is that the handle ICE? No, that's the add peer. So this is on the room peer joined message. Okay. Okay, so we create our own bin just for the individual peers. Interesting, interesting, interesting. Okay, so I'm just thinking about this. So if we're maintaining our own pipeline for an individual peer, we might be able to maintain that as individual inputs or outputs. So yeah, let's follow this train of thought a little bit, because that would save us from a massive refactor. Add ghost pads for connecting to the input. I don't know what a ghost pad is. So what is GStreamer ghost pads? What? Oh, I guess when I upgraded Edge, I lost all of my stuff. I always forget where to set this. Where are you? No. There we go. Okay. Fixed. There we go. Okay. All right. GStreamer ghost pad. I want to know what that is. All right. Ghost pads are useful when organizing pipelines with GST bin-like elements. The idea here is to create a hierarchical element graphs. The bin element contains a subgraph. Now one would like to treat the bin element like any other GST element. This is where ghost pads come into play. A ghost pad acts as a proxy for another pad, thus the bin can have a sink and source ghost pads that are associated with the sink and source pads of the child elements. So I think this is where like we name the ghost pad and they find each other. So okay. Audio sync. What did we name audio sync in here? All right. Okay, right here. So here's our... This is where we're requesting a static... No, that's the name of the static pad. Okay. Okay. Began, welcome. Thanks for the raid. We are exploring WebRTC in Rust. Cillian, thanks for the follow. So, is anybody here familiar with WebRTC? And Dr. Doomenberg with the pink. You know, we got to switch this up a little bit, Dr. Doomenberg, too. Like, maybe do, like, I don't know, some purple on the electronics desk back there. There we go. And I don't know, like, I don't know, blue ceiling. There we go. So what is WebRTC? Very good question. So if you're using like online chats of any kind, you know, Google Hangouts or, you know, Zoom or things like that from a web browser, you are using WebRTC. And so it's basically a specification, you know, since getting rid of things like Flash, for browsers to be able to have access to your camera and microphone and screen sharing. And it does a peer-to-peer communication. So it's extremely low latency for things like that. But scaling obviously is harder, right? We can't get a ton of participants because there's no central server that's actually handling all of the video feeds and compositing them together. All of the feeds are being sent to you individually. So we're currently looking at, I guess I need to pull up my own link here to our project that we're building here. So we're currently building like this project in order to pull in individual streams, mix them together, and send them out. So there's a couple of things we want to do is for like a producer view to be able to preview inputs before putting them live. It would be nice to have like just a WebRTC window that has each one of these as a participant. The other thing that would be cool is to have something running in the browser where you could just go and share your camera and microphone and have it fed into our mixer. Hi, user 129835. M Taggart and Spencer Underground, thanks so much for the follows. Yeah, so that's what we're working on now. But what's really interesting is the way WebRTC is managed. So there's the individual kind of protocol that the clients communicate with. Maybe we can just scroll down here and look at kind of the pieces that we've figured out. So we'll put a client here. Okay. Okay, so let's say we have these two clients on different sides of the internet. Here's what happens. So there's going to be a central server here, signaling server, and web sockets. And all right, let me turn off Dark Reader here because this is like what messes that up. Okay, so we have this signaling server here, and this is all done over WebSockets. So what will happen is this client will communicate over the WebSocket to this signaling server saying it wants to join a room or it wants to connect to some known client, right? This will then communicate with this client, and I believe it's just called an offer that it sends over this side. This client then needs to respond back with an answer. And then what will happen is it will allow these two clients to communicate with each other directly, right? Now, there's a couple of additional pieces here, though, that we have to leverage, and those things are called stun and turn. Okay. And I always mix the two of them up. Stun is the thing where basically the client reaches out to the stun server and asks it, like, what is my public IP address, and am I behind a NAT, a network address translation, and what kind am I behind? So it's then able to use that to figure out how to negotiate a connection directly between these things. And in the event of specific types of NATs, it might have to leverage a turn server as a proxy between the two clients. Obviously, we add latency if we have to go through the turn server first, but it allows for certain types of NATs that you can't get around. Pretty cool. Thanks for patiently explaining. No problem. I actually really love learning about how things like this work, and I love explaining it to other people too. Rust is nice, but choosing it over TypeScript limits your reach into what you can do. I mean, as far as what runs in the browser, I'm not decided, right? But Rust on the back end makes a lot more sense just because of our integrations with C-level APIs. Yeah, I typically just use libraries, but hearing it, I am like, oh, I could have designed that. Yeah. And so what's really, really interesting about how all of this works is there's no formal specification here on what this signaling looks like. Now, as far as like, there's something called ICE, which is how offers and stuff like that are done here. That is a decided upon protocol, but how the signaling server works, you invent that yourself. How does this scheduler work? I actually am doing a project utilizing a scheduler right now, and I'm a bit stuck on starting. So this scheduler is actually being written by a coworker of mine, but it basically just maintains a calendar and does things. Is that the type of scheduler you're talking about? Or are you talking about doing something like bin packing to decide where things go? So what we are currently doing right now is inside GStreamer, we have like an example of a WebSocket setup. And so we're kind of walking through the code and understanding it. But here, let's WebRTC, I guess we can go to send receive first, because I know how this one works. And they have a bunch of examples in, different languages, right? So you could use any of these. So we're going to do a cargo run here. Oh, we need what's the URL for this? Tab new, send receive, GSD Rust, source, main. Okay. So I forget where's the URL? Here we go. WebRTC nerd. All right. Okay. So Babu, thanks for the follow. So we can take this ID here and pass this. So we're going to do a peer ID equals 578. Okay. So we're going to allow our camera here. All right, why is this not working? Interesting. So we used this before. Ronnie is coding and Purple Chirp and MK Thanks so much for the follows. How does your, wait, oh, you already asked that. Is that a small can? Can of, like, this? The tea? Oh, 570 is not found. 4,300 now. Okay, so I know we tested this, was it Monday? There we go. There we go. All right. So the reason for that is actually we need to come into settings here, and I need to find the camera. It's defaulting. I have a hardware capture card with 2 HDMI slots, so it's defaulting to the wrong one. Okay. So basically what this whole pipeline is allowing us to do is it's capturing our microphone and camera on this side and feeding it in to our pipeline on this side so that we can play it locally. And we could have sent this anywhere, and we're already doing that with like the switcher that we're building. And then we're generating a test video source on this side, and we could have made it play a video or whatever, and then sending it out the other side. Sympathy, how's it going? So we're kind of looking at how all of this is implemented, because what we want to now tie that into our actual design here so that we can leverage it as both an output and an input. Doing some Rust stuff, but we're actually digging into how WebRTC works and how we can implement that so that we can use WebRTC coming from the browser as a video and audio source into our stream, as well as use it as an output where if we wanted to send the stream back. So the idea here would be a couple of use cases. One would be this would run in the browser as a producer view so that you could switch between each of the inputs as a preview before you made it live in the mixer. The other thing would be so that people could go to a browser and share their screen and camera and use that as an input and not have to use OBS if they didn't want to. And, you know, potentially maybe do like multiple participant calls where multiple people could get on and we could feed each of their inputs in as individual inputs or as one big one. In addition to that, maybe send them back what's coming out of the mixer so that you could basically see what's on the screen at any time. So if this person was live input and they were sharing their screen, that would be coming out the mixer, but we could feed it back to all of the participants. Is it Fin Night or is it FFF Night? I'm always curious, like when I see names like that, like what's the desired pronunciation? I'm gonna call you Finite. Yeah, there we go. But thank you for the follow. Yeah, Sympathy, have you ever done WebRTC stuff? Yeah, so we were kind of, that was the other thing. I wanted to walk through the multiple example because I hadn't seen that yet. So we had the multi-participant send receive. And I have not played with this example yet, so... Ooh, there's multiple versions of it. Wait, what? What am I missing here? Oh, it's part of my prompt. Okay. Actually, I've only ever done a tiny bit of Python scripting and some C# game dev. That is all the dev-related stuff I know. Well, it's cool, though, because you slowly learn more. I actually miss some of my early days in programming because it's so exciting every time you figure out a new thing. And then once you've been in the field for so long and you have, like, this foundation, learning new things requires more effort. So, but I get excited. I actually really, really love understanding how things work. And I've always been that way and always fascinated by it, especially when people have like really creative solutions to things. And so this is going to show my age a little bit. But one thing that's always really blown my mind is the original Nintendo. Right, had this game called Duck Hunt, right? And you had this gun that plugged into the Nintendo system, right? So here's the crazy part, right? Nowadays it doesn't surprise you that, you know, TVs have cameras and proximity sensors and all kinds of crap in them, right? So it wouldn't surprise you, but in the 80s, how did the gun work? Right? Does anybody actually know the answer to this? Because I'm going to tell you, but it's actually really, really fascinating. So this is how creative people are. When you shot the gun, you would notice the screen would flicker. Yeah, exactly, Sympathy. Yeah. And so the flash wasn't actually an effect. It would turn the screen black and white. And then the gun actually had just a light sensor in it, and it was able to detect whether or not you were aiming at a duck based on, you know, being able to see white. And so like that type of stuff just fascinates me because somebody thought of that, right? And so like oftentimes like I'm more fascinated by older technologies where people had less to work with and they had to get really, really creative for, you know, how to save memory or disk space or do things like that. It doesn't work on flat screen TVs. That's interesting. Is that just due to the backlight, Sympathy? Oh, okay, so we need a room ID. So we need to figure out where this is going. So there must be a way for us to, in here. All I know is I found a bubble TV and then it worked. Okay, so we need to figure out here how we can do this, because here we have an example, but their example code doesn't show us how we can specify a room ID unless it's something. I know that inside their code we can actually see their source code for that. It is in nope. Okay, it's not in there. Is it in signaling? All right. Room. Oh, so this is coming over the WebSocket. But we need something in the website that's doing it. I know that I've seen the website code somewhere. Let's go to send receive maybe. There we go. It's JS. There we go. Room. And there's nothing in there that's room related. Of course not. So we're gonna have to build our own room logic. The fact that they could do color on an Apple II is a huge hack. Yeah, yeah. Okay, so I'm trying to figure out how we're gonna do this, right? Like, so I know that we can pass a room ID here, right? Okay, room ID 1024. I don't know. Okay, so this is playing whatever in that room. Does 5660 count as a room? No. How are we going to do a room here? No. Okay, so they must not have any support in their like example here for a room, which is kind of sad. How are we supposed to test this? I think the most creative hacks back in the day were with video games. Absolutely, yeah. I like how they compress reuse textures in Zelda's Ocarina of Time. Yeah, yeah. Okay, so we need to figure out how... Well, I guess if we ran this twice... Oops. If we ran this twice, maybe we could get... Because I'm sure it's sending something in that room, right? Wait. Okay. Cargo run, room ID equals 1024. We're just in... Oops. Okay. Examples, WebRTC, multi. Okay. Wait. What am I missing here? I can't type today. Okay. So this is for here. There's nothing in there, so let's see if we can get this to join a second time. Room ID 1024. What happens? Okay. So that kind of works, right? What's interesting is, being able to send the stuff. Yeah, so basically we're joining as a peer, and it appeared that they were sending each other their own streams, right? So, and I mean we could have sent whatever we wanted as part of this pipeline, but effectively what we're getting here is what is coming back from the channel, except that SMPTE test screen that you saw is actually being fed by this client. So what we're seeing here is this side sends it so that this side sees it. So, okay. So what we're looking at here is kind of like how that stuff is managed, right? So here is where we were handling kind of the WebSocket logic. So it looks like it's just kind of like a string protocol back and forth. So we're getting this room peer message, and then it looks like a space. And on the other side of it is going to be the peer that we're wanting to talk to. And then we're asking for the peer, dropping our lock. And then what's after it is the message that we're sending to the peer, which appears to be JSON. And this is our session description protocol and ICE messages, which is where we're like offering those exchanges. And if you weren't here Monday when we were working on that, we can pull up this this post that I was looking at that kind of explains how all of that stuff works. which isn't going to be in my history because for whatever reason, when I upgraded to the new beta of Edge, I lost all of that. Okay, so here it looks like the peer joined or peer left. Okay. I don't know what remove peer does. Let's go find it. So we're first deleting it out of there, taking ownership of it. Okay, so this is one of the things that we actually need to do in our other stuff before we disconnect. But so this is just adding a probe to the pad to block it, to stop data from flowing before we actually delete it. And then we're getting the static pad, grabbing the thing it's connected to, and then unlinking it. Okay. Okay, so this is just removing it from the pipeline. What I'm really curious about here is let's generate a graph for this. So we can do a .env_rc grep gst. Okay, so this is what we want. Okay. So if we run this, what we're going to be able to do is maybe not. Why did it not generate our pipeline? Okay, so we're missing something here because what we should get here is dot data. Basically, how we've previewed our pipeline in the past in the browser, this should generate that, and I'm not sure why it's not doing it. And I mean, we could add a call to make it do it if we wanted to. Hey John, how's it going? Okay, so this is that's removing a peer. Let's see, where's our add peer? I'm curious what that looks like. Okay, this is all just getting our peer ID. We're setting up a queue and a WebRTC bin. Okay, so we create the WebRTC bin, and then this is queues for the audio and video side of it. But what I'm curious about is we have both incoming and outgoing. So which side of this is it? Okay, peer bin. Audio queue. Okay, so this is just getting binding variables to gain access to these. Where's audio sync pad coming from? Okay, so here's our callback for on negotiation needed. And here's where we get our candidates. So what's happening here? We get our candidate. Here's our peer. An on ice candidate. Okay, so here's where we're doing something. This is every time a new peer connects to us. So whenever a decoded stream comes available, handle it and connect it to the mixers. Okay, so this callback looks like this is what's called when we actually have a connection from somebody else. So we have an audio mixer and a video mixer. So this is going to be, I think, a kind of challenging project to build. I really want to see a diagram, but it looks like that we have... where's our video test source? Test source. Okay. So this compositor and test sources is at the app level. Not at the per connection level, right? And same thing, so video mixer and audio mixer are also at the app level. So this represents us on our side. Okay. And this should be going to an auto audio sync and auto video sync. Okay, so this is making more sense. Let's diagram this for a second. We're going to just keep going down. So it looks like we have our audio and video mixer. Marco, thanks for the host. Okay, so we have those, right? And these are just, I guess we'll build another box here, right? We're just gonna call this audio and video sync, right? We don't really care how this is implemented. Right now, it's just going to that little browser or that little window on the screen. Okay, so this is sort of the flow, like right out the gate. However, I think what's happening here is when we get a client connection, which is peer-to-peer, right? This is like ignoring all of the WebSocket signaling and negotiation that takes place. This is just, once all that's happened, it looks like we're then connecting the audio and video from that client directly to that mixer. So that's interesting because then that would mean that if an additional participant were to join, we would end up just stacking their video directly on top of the other person. Now, what I don't see yet is what we are sending back to the client. All of this makes complete logical sense, but I want to know what this is getting. And my guess is, aside from ourselves, right, because we are also a client, I think what happens is that coming out of our mixers, we're feeding all of the clients the output. Right, so if we had another one down here, so from what I see, this looks to be what the flow is like. Which, interestingly enough, is kind of what we want to do for one of our use cases, right? And that was like if we wanted to bring you in as an input, but then send the result of our switcher out to each of the participants so that they could basically view it with no latency or minimal latency anyway. Okay. So I think this makes sense. And I mean, and we could, you know, change what all of this stuff is, right? Where do we begin? Imagine falling for the Rust meme? What do you mean? We're gonna have to get rid of all these anyhows too. I wonder if we should start with individual peers here and work our way up. The other thing I think we need to do is implement the browser side as well as the Python server that they have for signaling. Right, because none of this is actually handling the WebSockets from the server side. So I wonder if, like, what do we want to build first? It's peer removal and relay video mixer. Okay. We don't support more than 16 streams for now. Oh, wait a second. I think that this is actually compositing people together. Hold up. But what's it do about audio? Wouldn't you hear yourself? All right, hold on. Let's try something really quick. So I need to adjust the oh wait, wrong one. So what I want to do is coming out of the audio mixer. Oh, okay, so this is muting ourselves. Gotcha. Okay. So we've got this audio mixer that we're sending everything into, but so let's see if we can set volume to 0 here. All right. Let's get multiple participants because this actually looked like it was going to start drawing people. So if we did this, all right. I muted the desktop audio just because that's going to be annoying. All right, I want to try something really quick. Oh, wait a second. Let me try this really quick. I think we can do that here. GST inspect audio test source. Oops. Okay, yeah. So we do have a volume property on here. So we're going to assume volume works anyway. So now we should be sending only video. And we could have done, you know, a bouncing ball or something like that too. Okay. So there's that one. Here's our second one. Okay. So now, in theory, if we were to do another one, cargo run, room, ID, it should composite them. Wait. Oh yeah, look at that. So it's drawing them side by side. All right, let's update the code and we'll use a different test source that should make it a little more obvious what's going on. Oops. So here, if we look at our GST inspect video test source, right? We have not animation mode. It's pattern. Here we go. So if we look at pattern, we've got a few things, right? So we can do snow, we can draw boxes and things like that. So, but the moving ball is probably the thing that we'll notice the most. So if we come up here to video test source and we set pattern equal to ball. And I think that this is the background. I'm going to test this real quick. So it's already doing some magic here. Oops. Okay. So they're each viewing each other's, right? But if we come in here and we run a third one, we should see they're kind of side by side, right? Nice. So they're already doing something with all of this. So what was that called? Mixer something. Okay, the relay out video mixer. So this is I'm guessing this is copies, right? That's why it's removing it. All right, so we're looking at the number of pads with height 1 1. So what is this doing here? So X is going to be set to 0, Y. Okay, so everything's starting up in the corner is what it looks like. And then the width. So this is getting the total size of our window divided by the number of columns we need. And this one's divided by the number of height. Okay. And then our X position, we're adding the width. So we're taking the width. Oh no, we're incrementing it by width each time, right? Because every iteration of it, we're doing that. Okay. And I'm guessing we're passing a reference here, because otherwise, what good would this do? Okay, I think this makes sense. And here's all the SDP stuff. Okay. Okay, so this is when we get an ICE candidate. We're just assembling a JSON message and then sending it over the WebSocket using that room peer message. And this is our peer ID, and that's our message. Okay, so it's basically accepting anything, right? But I think on ICE, can we come up with our own protocol for that? I think it's only here. Okay, and so this is when we actually get the stream. Oh, this is going to be a really tricky pipeline. So we're creating this like small part of the pipeline for each individual stream that comes in, right? So incoming stream looks like this could be for both called twice for video and audio, right? Nitinkura, thanks for the follow. There's a part of me that kind of wants to implement this from scratch to just sort of better understand what's happening, right? Like I haven't done anything with WebSockets. I haven't done anything with like all of this like select. So maybe as a starting point, what we can do is inside of, so here, signaling, we have all of the logic here for the server side of the signaling. So we could try to implement this end of it. And we could use probably this as well as that Rust program as an example. Oh, they've got a bunch of Let's Encrypt stuff in here too. And I guess the question is, do we have a need to rewrite this? I mean, because, in theory, we could just run this in a container somewhere and make modifications to the Python as we see fit. I mean, but I kind of feel like there's value in rewriting it to understand how it works, right? Okay. Yeah, I mean, the starting point is going to be the WebSocket. You know, whatever side we work on this, the starting point has to be the WebSocket, because that's the only way we're going to get signaled that anything's happening. So, where do we want to build that? Let's go back to our code here. Okay, so I can't. This may not even build. We may need to. Does this run? Interesting. Okay, so I guess we'll leave all of this for right now. Okay, so let's create. Okay, so let's create a WebRTC module here. And then we'll create a mod file here, mod.rs. Okay, so this is going to be our starting point. Oh, we need to put this in lib, right? Oops. WebRTC, okay. Cargo plus nightly watch Clippy, okay. Okay, and I'm gonna open up GST exam code. TST examples, WebRTC, and we'll look at the send receive example first. And we're just going to leave that open for now for reference. What is all this? Code switcher. Let's try that again. All right, crap. To create module, create file, source WebRTC.rs. No, I do not want to do that. I want... Wait, why does mod not work? ls source, right? We have an HTTP module. We have a input. What did I miss here? Oh, is that just because this just isn't saved yet? Okay, so, I don't know. Obstruct connection. We'll start there. All right, what on earth am I missing here? Oh, Rust modules. RTC. Wait, where is this? Oh, because I am an idiot. Move WebRTC into source. Okay. Yeah, I put it in the wrong place. Okay, so let's see, what do we want this to look like? So, impl connection. So we're gonna need a new. Okay. What's WebRTC going to roll in your streaming app? So, isn't mod.rs a 2015 thing? I don't know. It's just what I've seen and remember in examples. If there's a 2018 way of doing it, I'm definitely happy to change this. Oops. So Quinquan, the two main roles that we're looking at WebRTC for here is one for like a producer's view to be able to see all of the inputs live before putting them into the mixer. The other would be in order to take WebRTC as an input so that you could just go to a website and share your screen or your camera and then have the mixer grab that. So think of like OBS Ninja or something like that. Instead of pulling in a browser source or something like that, we could pull in the individual feeds themselves and do interesting things with them. What ModRS is the 2015 way of doing things. So what's the more updated way of doing it? You know, and actually, I mean, that's kind of a fun thing that we could do right now if we wanted to. If we wanted to kind of press pause on WebRTC, which is going to be a much bigger and more challenging effort, we could try to see whether we could get a browser source working. Okay, so Dark Reader, help me out here. Okay, so in 2015 you have a submodule. It can live in foo.rs or foo.mod if it has a module own. Okay. In Rust 2018, the restriction that a module with submodules must be named mod.rs is lifted. Foo.rs can just be foo.rs and the submodule is still foo.bar. So you leave it up at the top. So mod.rs, if I'm understanding this correctly, moves up and is just called whatever it is. Okay, so let's stash all this for right now. Okay. What are you doing? What, this is super interesting. Oh, by the way, my new keyboard gets here Friday. That's going to be a challenge. Okay, so that all compiles. So let's, yep, the Moonlander. It's supposed to be here by 9 p.m. Eastern on Friday. So Monday stream, I should have it, and you will watch me hate life as I relearn to type. Okay, so that's all stashed. So let's start looking at our individual. I'm going to just cd in here for now. What's an HTTP? All right, so we should be able to git move HTTP mod.rs to here as http.rs, right? I'm just gonna make sure it compiles and then we'll do all the other ones. It's definitely a learning curve. I went from standard keyboard to the ErgoDox Easy with Colmac layout. Took me weeks of practice to get close to the same typing speed. How many points to switch to Colmac instead of Dvorak? So I haven't even fully decided on switching to Dvorak. The way I see it is if I'm already going to have to go through the effort of relearning to type, I might as well also try Dvorak at the same time. So the mod.rs way of doing things is not wrong. So both are, you're saying both are valid, right? Git move WebRTC. All right. Yeah, I'm getting the Moonlander. Yeah. But 2015 and 2018 versions work since Rust likes doing the whole backwards compatibility thing. More just best practice and easier layout, I think. Yeah, and I mean, being it's a new project, I might as well, you know. Layout Rust modules in 2018 style. Okay. Okay. Some prefer the new way, some the mod RS is clear. There's no really an answer of which is the right way. Okay, I guess that's good to know. I've had a few people comment on it, so I just assumed that I was doing it in the old style and that I needed to fix it. Alright, I will be right back. I'm gonna use the restroom real quick. And then we will do some WebSocket WebRTC magic. RWX Rob, thanks for the follow. I'll be right back. Okay, back. All right, so I guess the first thing we need to look at is I have never done anything in WebSockets here. And so that looks like it's all done through like this tungstenite stuff. So we're gonna import all of that. And it looks like we're gonna have to do some futures things as well. Okay. Does Rust have 3-year edition lifecycle? I'm not sure. I don't think it has, to my knowledge, has like a set release cadence, but I could be wrong. Raimu, how's it going? Yeah, we are looking at doing WebSockets because we're trying to implement WebRTC, and in order to do that, we have to use WebSockets for the signaling. I think that's the plan, but may have read they won't force it if it's not needed. Are you going to make your own WebSockets crate? Is there like a disadvantage? Okay, so here we're going to have to manage a few things, right? So we know that we need signaling server. Why am I typing it in GoWay? Let's just call this server. String, we need the stun server, and then we need the turn server. Okay. Server. Okay. Maybe we should just signal server. Okay. Nothing wrong with tungstenite, just interested in, oh, okay. This is sort of like a learning experiment. Okay, so we know we have all of this stuff. Well, I guess let's go the other way around. Rather than looking through that confusing library, let's see if we can go find some docs for just tungstenite WebSocket. All right, I just want to see a basic example. Okay, so this looks like the thing that Musim was talking about before, and that's what we implemented in our cargo file, I think. Oh, wait, because git stash pop, right? Right, so here's where we use the Tokyo runtime, but wait, isn't there a standard error type in Rust? We've been using our own custom ones now, and now I'm completely forgetting. I mean, I guess I could just have it return back a WS error for now. We'll implement that later. Okay. So give me just a standard example of WebSockets. All right, here's what we want. We want a client. Oh, right, standard error, right, okay. No, I just want... All right, here's what we want. Okay. So this is the basics of it, right? So we're going to need to format this. All right, so this gets us back our socket, but I know in here we split the channels, right? So they're using something completely different, right? So we're going to be using something completely different though, right? Because we're going to actually use Tokyo. So this is the Dark Reader plugin. And, you know, we have the ability to kind of like adjust things how we want. But yeah, so you can configure it like for specific sites and things like that. But yeah, if you just look for dark reader, there we go. Okay, so we have to figure out, because there's some things that are different here, because because we're trying to use Tokyo because that's what we use for everything else. Tokyo, yeah, there is a connect async, so okay, so why is that failing? Is that just because of the error type that's being returned? Oh, because this is not a async function. Be good, what do you got? I guess this would work better, huh? Alright. Autobahn client and client. Okay. So here's a basic... Okay, so this is even better because this has where we're using this. I'm guessing MPSC stands for multi-producer single consumer. Okay, so let's look at this. All right, we're gonna copy all of this in. Oh, look at me. Okay. It's the challenge though too is like if you don't understand like what this type of stuff does, like you would never know what that even means. Okay, so we're not worried about that. I guess here we are going to need to pass in a URL, right? I'm going to say, yeah, let's just pass in signal server. Is it better to take in a string here or an and stir? I can never determine when the best use of... I feel like at some point, you know what? Let's not do this. Let's do a config here. And let's make this a config maybe, because I feel like we're going to have a lot more stuff here. So let's also do a pub struct connection, and that's going to have a config on it. There we go. If you're going to own the string, I recommend into string. Otherwise, if you just need to borrow, use as ref. Okay, so we have this config. Yeah, I'm gonna assume you give me the full URL. Signal server. Okay. That would be in the config new function now. What do you mean? That would be in the config new function now? This is the impl of the connection, right? The config we don't have anything for yet. Oh, right. We need to do. All right. Ibio83, thanks so much for the follow. I don't know why I'm not hearing my alerts. Yeah, see. Vinicius, thanks for the follow. All right, let's go here. That was a test. Nobody actually donated $100.
Someone finds you interesting, sir. It appears we have a new follower.
Weird. So the test one plays a sound, but legitimate ones do not. So unless somehow, like, it got, like, no, that disables it. So that's not what we're looking for. I thought there was like a global settings one or something, like somehow it's maybe ending up in there. I don't know. That's so weird.
Wonders may never cease. We have received a new subscribers.
Finit, thanks for the sub. Refollow might re-trigger it. If you like unfollow and follow again, it might. I really appreciate the sub, Finit. Okay, so now we're gonna figure out what all these errors are. Method not found in Tokyo IO standard out. All right, so we are clearly missing some sort of use statement, would be my guess. Let's go ahead and pull in all of this. That's actually one of the bigger frustrations I find, is when there's a trait that implements some function and you don't know the existence of that trait. Thanks everybody for hanging out. I really enjoy, like, I love the fact that everybody like hangs out while I build this stuff, especially because like some days there's like zero progress and it's just like me exploring and poking and prodding and trying to figure out how I'm gonna design stuff, how things are working. Okay, so why are we getting an error there? I'm guessing because I don't have, like, in my cargo file, I don't have the futures util. So let's go look at so I guess we're gonna pull that in as well. I need a better way of like organizing some of these things. Okay. Okay. 5 breed standard in, not found in this scope. I think that's something we don't care about, right? So I think what this is trying to do... Hold on. All right, we're going to have to remove some of this stuff because this is not what we're doing, right? So let's comment that out. So this is only just so that our binary will take in some sort of standard in from the command line. We don't really give a crap about that. All right, so we are creating our... Oh, we don't need that either because that's from standard in, right? So this is just a filter through the WebSocket. Okay. Okay, so now now we've connected. Now we have the right side of our stream and the read side. Okay. And this looks like we're mapping the read side of our standard in to the right side of our WebSocket. Okay. Alright. So we don't need all of this. I don't know what pin mute does. What does that do? So what is returned back from this? Pin mute pins the future to the stack. It pins the future to the stack. It won't, the pointer won't move across the waypoint, so it'll have a stable address. Interesting, okay. Alright, so we really don't need all of this, right? So I guess this is the point that becomes interesting, right? So now we have the read and write side of the stream, so I guess the other thing we would have is a room ID. I'm going to use a string here, and also a peer ID. I don't know. ID. Alright, I think this is sort of what we might need. Okay. Futures in Rust don't have their own stacks. It's just a state machine of every yield await point, and it restores that when the function stack is restored. All right, let's pull that up. Oh, there's an async book. I guess I know what I'm reading this weekend. To pull futures, they must be pinned using special type called pin. If you read the explanation of the futures trait in the previous section, executing futures S and stacks, you'll recognize pin from the self, pin mute self, and futures pull method definition. What does it mean, and why do we need it? Pin works in tandem with the unpin marker. Pinning makes it possible to guarantee that an object implementing unpin won't ever be moved. To understand why this is necessary, we need to remember how async await works. Consider the following code. So to make sure the data referenced by the future is the same place when the state is restored. All right, why would the data need to be in the same place in that example? Oh, they're not done with writing the book. Okay. So we're looking at an example. So we have two futures. And then we are moving those futures. And then we are awaiting them. Okay, so under the hood, this creates an anonymous type that implements future, providing a poll method that looks something like this. Future 1, future 2, and maintains our state. Okay. Awaiting future 1, awaiting future 2, or done. Okay. If the pointers get invalidated before the stack is restored, you now have a huge problem. Okay, so this is sort of how the poll method is implemented. We're just looping, looking at the state. We're waiting future 1, then we look at future 1 and we poll it to see whether it's ready or pending. If it's ready, then we move to awaiting future 2. Okay. Okay. This makes sense. So when poll is first called, it will poll future 1. If future 1 can't complete, async future poll will return. Future calls to poll will pick up where the previous one left off. This process continues until the future is able to successfully complete. However, what happens if we have an async block that uses references? For example, okay, so we have an array of length of 128. We are reading into a buffer. Okay, so read into buffer is just hydrating X. Okay. Except it's returning a future, and we're waiting on that. Okay. So what struct does that compile to? So we get a... So this is a reference to a mutable slice of U8s with a static lifetime A, right? Or a lifetime of A. Okay. So then our future has X, and I'm guessing this is a placeholder because that makes no sense. Okay. So here the read into buff future holds a reference into the other field of our structure, X. However, if async future is moved, the location of X will move as well, invalidating the pointer stored in read into buff. Pinning futures to a particular spot in memory prevents this problem, making it safe to create references to valid values inside an async block. Okay, I think I understand what this is doing. I think this is the type of thing that I'll have to read like 16 times before it's like fully committed to memory. But okay. All right, so we have one error here, not found in URL. Is there a URL package that I need to include? Yes. Dev dependencies. Okay. So cargo. Cargo. All right. URL equals 2.0. That pinning in detail section gives an easier example showing some pointer invalidation. Okay, so this is a different. So let's try to understand pinning by using a slightly simpler example. Well, why wouldn't you start with the simpler example? The problem we encounter above is a problem that ultimately boils down to how we handle references in self-referential types in Rust. So for now, our example will look like this. Okay, we have a test struct with a string and a... See, so this confuses me in Rust. Like, what does this mean? Like, because star doesn't actually mean it's a pointer in Rust, right? Oh, it is a const pointer. So sometimes this means deref something, and sometimes it means it's a pointer. Okay, so... Okay, so here we're just getting a string from our answer. Okay, and then B is just, we're just a null pointer. Okay. Init is getting A from... Oh, so this is getting the string. It's getting a const pointer to the string. Okay. And then it's setting B equal to here. Okay, so we have A, and then B is really just a const pointer to A. Okay. And then this is just a return back A and B. Whoa. Okay, so this is what? A borrowed pointer to self B? Right? Well, self B is a const pointer. So are we getting a pointer to that, or is this dereffing it? It makes a reference from a pointer. Okay. All right, so test provides methods to get a reference to the value of fields A and B. Since B is a reference to A, we store it as a pointer since the borrowing rules of Rust doesn't allow us to define the lifetime. We now have what we call a self-referential struct. Our example works fine if we don't move any of our data around, as you can observe by running this example, okay? Okay, so we get what we expect. So if we swap test1 with test2 and thereby move the data, okay, natively we could think that we should get a debug print of test1 two times like this, but instead we get test1, 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 B, test2. The pointer to test2b still points to the old location, which is inside test1 now. The struct is not self-referential anymore. It holds a pointer to a field in a different object. That means we can't rely on the lifetime of test. Okay, so I think that this makes sense, right? So when we move the value in memory, it's not going to go into that value and update any pointers. So then we end up getting basically a pointer that points at like an old location of memory. When we use pinning, we ensure that even if we move it across threads or something like that, that the memory addresses stay the same. Okay. Now the question is, when I run into this problem, will I remember this? Okay. We still have not... What do you mean, Tokyo? Oh, because we have async tungstenite. But I should be able to do a... I should be able to do a use async tungstenite Tokyo, right? Yeah, okay. So async tungstenite Tokyo. There we go. Basically just pin mute before doing something to keep it in the same place on the stack. You'll get some errors, but about... Okay, so the compiler will actually pick up on that. Okay, so this is our connection here. So this looks like what we need to do. Okay. So it doesn't look like we have to split it. I'm going to comment this out for now. Okay. All right, so our ID something we're going to have to do here is to do, if we don't have an ID, we should generate a unique one. Okay. I've been gifted free programming skill. I've been waiting for this. I never win anything. It's about projecting fields of structs into view structs which borrow from the real struct. Wait until you get into pin field projection. I have the feeling this is going to be a lifelong journey of learning Rust for me. Okay, so, oh, we got some heavy errors. Okay, so we could not find tungstenite in Tokyo. Oh, okay. Wait a second. Oh, so we should be able to just do like Tokyo connect async, right? Okay. Welcome to the async rabbit hole. Okay, so here's, what do we have? Okay, so this is all the anyhow stuff. I don't really care about anyhow here. So I should be able to just do this, right? Okay. Okay. So we're getting like an async tungstenite error. So we're gonna have to implement all of this error handling logic first. Oops. For now, this should help. Okay. Aren't you one of the lead designers of Rust? Who are you referring to, Void Rose? Definitely not me. I just started learning Rust like maybe a month ago. I mean, I've been more active in the Go community than the Rust community. But how you can get zero cost abstractions for it in a portable way. Yeah, and that's sort of the appeal of Rust, right? Like, that's the one thing that I do like. You can get some of the programming paradigms in modern languages, but, you know, we can compile this down to, you know, embedded hardware. Rust async stuff definitely been tricky compared to my experience with Golang. Hopefully all worth it though. Yeah, I will say that doing async code in Go seems much quicker, but you know, that's not to say one is better than the other. It just depends on the use case, right? So like, as I've learned Rust, I think there's still going to be some use cases where I'm going to use Go, most use cases probably for Go. But then I think that there's also, you know, a lot of places where I think that I'll find myself using Rust as well. The trait standard convert none error is not implemented for. Okay, so we're returning back several different error types here. Let's just do this for now. Expect failed to send message on WebSocket. Okay. We're just going to use expects for now. We'll fix it later. Failed to read message from WebSocket. Okay. Oh, wait. Next returns back an option. So I would need what? Okay. Or? Right? Why are you not completing? Because if this isn't option, right? Okay. And so what's this, the same thing? Yeah, okay. So here we need an okay or else, right? I don't know what I'm returning back here, but we'll unwrap it for now because this is just me experimenting with WebSocket code for the time being. Okay. So, this is one error that we did find. Send is not a method, right? On a WebSocket stream. So what methods do we have here? So do we need to split it? Is that our issue here? That Tokyo's version of it, we don't have a send method. We have to do something else. Okay, so here's write. Prototyping in Rust be like slap some unwrapping clones until it compiles. I'm glad I'm not the only one. I basically do that and then I go through and make it cleaner. You should have send. It comes from sync in. Okay, so the issue is that I'm not importing the traits. So I know that we did that in here. Right? I think we started messing with this. Okay. Okay. Multiple next found. Wait, what? What are you trying to tell me? Multiple next found. Oh, okay, so one is in Futures Util, the other one is in Tokyo Stream. Okay, so... is that what we're looking for? I feel that when you first start with Rust, you unwrap a lot, and when you start feeling comfortable with result option and the operator, it's like you've graduated a level. Okay, so I'm not sure which one of these I'm supposed to want, because it's in both sync extension and stream extension. Oh, because we're doing stream extension from Futures Util and from here. Okay. Not equal, cannot be applied to standard result. Okay, so message is a result, even though we've unwrapped it. So what is the first thing it returns? Cannot borrow as mutable. All right. All right, I think we might actually have basics of a WebSocket connection. Okay, so let's Let's open our switcher here, and then rather than doing all of this, we are going to use WebRTC. Oh, I don't need to use that. Okay, so we should be able to do a let config equal WebRTC config, and this would be signal server. All right. We are going to steal some stuff. So that was stun server, right? I still don't like that, but turn server. Okay. Our ID, I don't know, 1, 2, 3, 4. Peer ID, we're going to leave blank. This should probably end up being an option. And then we need, where's our WebSocket? There we go. Okay. So we're going to see whether we can try and like connect to the same WebSocket that the examples are. Use of undeclared crate or module WebRTC. Why? Why are you undeclared? Oh, use switcher WebRTC. There we go. Okay. OXC45, thanks for the follow. All right, what am I missing here? Oh, it's just ID. Due to inaccessible. Oh. Okay. Missing room ID. Oh, not there. Room ID. Okay. All right. So now we should be able to do WebRTC connection new config. Oh, so it actually compiles down to it. Nice. Private associated function. So pub async. Okay. So now in theory, we should connect to it and do a hello. We're going to find out. All right, it said it ran. So my guess is that hello is what it returned. And I suppose we could have printed out what that is, right? Message. Okay. Okay, so that didn't work. So now I'm curious. Server responded with. I feel like that didn't. Does it have something to do with our to-do here? Oh, wait. Yeah, because we need to return back. What am I missing? This should panic, right? So all of these things have to be taking place. We're calling all of this. All right, we're gonna have to do some print line debugging here. In new. Connection created. Hello, sent. Oh, crap. You are right. You are absolutely right. Unexpected token. Okay. Let's try this again. I actually historically have not done a lot of code that uses futures and promises and things like that. There we go. There we go. Okay, so what is this doing after that, right? Pasta, thanks for the follow. Okay, so after this point, this is where we're kind of negotiating with a peer. So let's change our config up a little bit here, right? So I think that we should probably have make these options, right? Okay. So we should do a couple of things. So let's get rid of all of this, right? Okay. So now we've got a few things that we probably need to do from a configuration standpoint. So the first thing that I think we need to do is, no, let's get rid of that. Okay. So if config dot ID is none, then we need to set config.id equal to something. And actually, we did this already in web source input WebRTC. We already figured out, oops, the rand package on Monday, right? So this is basically what we ended up doing, right? Mr. Demon Wolf, how's it going? All right, so I don't know whether this is going to be taken, right? So this is probably not the best way to do this, but it'll work for now. Okay, so if we don't supply an ID, we're going to just generate a random ID. Oh, right. Okay. I delay Windows updates to the maximum 365 days because of the fun. See, I do the reverse. I end up upgrading everything and then nothing works, like, all of the time. So, like, for instance, like, is my frame rate okay? Oh, I guess it is. I'm not using the hardware encoder. I have 2 GPUs in this thing, and I'm not using the hardware encoder because somewhere in my kernel and NVIDIA updates, I broke something, or the fact that I'm running OBS at a very, very, like, bleeding edge version too. So, like, I'm always messing with crap, and then it doesn't work, and then I'm frustrated by it, but it won't stop me from still upgrading everything. Okay, so here, I guess here it would be, well, actually, right, we could just do an unwrap or, right? If we did an unwrap or here, we would be able to provide a default, right? So that's probably the better way of doing this, right? So we don't even need to do that. Well, no, because is this Arch Linux running in a VM? It is not. This is Arch Linux running directly on the host itself. Are you the daily updater? I am like the hourly updater, Quinquan. I run like sudo Pac-Man like whenever I get a free second. If I'm just bored, it's like a fidgeting thing, you know. Rather than playing with a fidget spinner, I just run updates. Blame NVIDIA because Linus says so. I read NVIDIA broke the driver on kernel 5.9 and are working on a fix. NVIDIA broke the driver on 5.9. Is that what I'm running? Top Shosho, thanks for the follow. I am running 5.9. So, Strauss, maybe that's my issue. Do you have a link to that? I'd be really curious. NVIDIA and Linux don't mix very well, I always hear, as everyone has issues one way or another. Yeah, my issues with Linux typically are video driver issues or audio issues. They're a lot better than they were when I started running Linux on the desktop. Too many years ago, probably, to admit. Option replace is nice. Ooh, what is option replace? Option replace Rust. Okay, so in this case, I wouldn't know whether it's some or none. I would just be replacing it. Okay. Well, actually here, option get or insert would be more applicable. Get or insert. Does it also return back the value if it does insert? I'm guessing. So here, so we'd have like a get or insert. Okay. All right, let's see. This will make me feel better that it's at least like not something crazy with my system and that I just have to wait. All right. Well, NVIDIA is usually quite timely in supporting new versions of Linux kernel and aim to have driver by the end of release candidate. It's taking a lot longer. They send an advisory to their customers that they don't expect to have a 5.9 kernel support in the proprietary graphics driver until mid-November. Okay, so we're gonna have to figure out how to roll back my kernel then. Because I need the NVENC driver, especially because we're going to be doing a bunch of GopherCon stuff streaming off of here. Okay, yes, it gives you a mutable T back, which you can just ignore. And the underscore with one is deferred lazy. You can always... Almost never needs to do unwrap. Okay. All right, so what error do we have now? Message is not a future. Wait, what? Did I mess up my parentheses? All right, that's my format. That's the get or insert. Okay. There's the message. Okay, so we're just missing one. Okay. How to switch Arch Linux kernel. Okay, yeah. So I'll do that tonight or something that way. I cannot borrow as mutable. Ooh, oh, okay, so this is just inside of our switcher logic here. That is just because none, right? None, okay. Do you use Arch install scripts or just punch in each command as you go along? You mean as far as like installing Arch? I just install... I can almost do it like without any reference materials. I mean, I've been running Arch for, I don't even know, 10 plus years or something like that. No. When did I start using Arch? I can't remember. It's been quite some time though. Okay, now we're compiling again. Yeah, LVM is. And for some reason, I always need to look up the commands to do disk partitioning. I think I just don't do it often enough. I always have to look that up. I never remember the commands for that. Okay. Okay, so now we have this. I guess the next step is that if we have a peer ID, request session with peer, right? So that's going to be the next thing we're going to do. And we might write our own WebSocket protocol for all of this stuff, but okay. All right, so if we have a peer ID, then we're going to run the session command on the WebSocket. We're going to pass it our peer ID. Okay. Right. I guess here we have our unwraps too, right? I'm still not entirely sure why we have two here, but okay. Okay. So this should set up our negotiation, right? So if we come to here and we just grab that, right? That 1761. Seventeen 1761. Okay. I use CF disk, I think. The first unwrap is for the stream option. The second is whatever the item inside of the stream. It's probably a stream item result. Okay, gotcha. All right. All right. Okay. So now we're passing that in. This should negotiate the session. Nope, here. Okay. Let's try it. The one thing I think we should do that would be really interesting too is to try to reverse engineer the signaling protocol with to reverse engineer the signaling protocol with OBS Ninja. I kind of want to try that now. I think that would be really fun. Okay, so I'm assuming all of this works. Tokyo has a concept of codecs, which are pretty neat. All right, we're going to use you. We're going to do no audio here. No audio. All right. All right, so here's our WebSocket. Okay. Let's turn our audio off. Because we could reverse engineer this and get our code, right? All right, so request seed stream ID. Anybody want to see whether we can reverse engineer OBS Ninja? And see whether we can get our code to push data to or pull data from OBS Ninja based on that? LW Brits, thanks for the follow. Because, I mean, this is pretty straightforward, right? Yeah, so I think all we have to do is send this message, right? All right, let's do this. Okay, I'm in. I mean, that's the end goal, right? So let's, okay, we're gonna do GST examples. We are going to go into WebRTC. We're gonna go to send receive, GST Rust. Okay, so now we have a WebRTC. GST examples, WebRTC, send, receive, GST, Rust. Okay. I need like a hotkey to like make all of these go at one time. Send, receive, GST, Rust. Okay. So here's our starting point. So we need to figure out the signaling protocol here. I mean, maybe our example code would have been the better way to start. And then we move to here. Right? I don't know. We don't really have an incoming stream though, right? So this is really only to send our data somewhere. So maybe the better thing to do here, because how are we requesting it, right? I guess that would be the other thing. So let's open another tab. I'm just gonna leave this here. And let's open this, because what does the requesting side look like, right? So this is when I'm trying to send stuff. But what does it look like if I'm trying to receive data? All right. All right. View. What does that look like? Is that the raw data? So this is encoded somehow. Okay, hold on. What do we have? So yeah, OBS Ninja is like a WebRTC. So there's no such thing as a WebRTC server, right? So WebRTC is implemented in the browser for sending audio and video streams places, but the connections are actually peer-to-peer. Now there is a server that's a WebSocket, but it's only used as a signaling server. So I send a request to the WebRTC server saying, hey, I'd like to join this. and then it forwards it on to the other participants, and then we connect each other directly. Hit the curly braces on the bottom. Yeah. Patrick, thanks for the follow. So this is interesting though. It looks like it's like an minified and obfuscated version of something. So it looks like the signaling server is handing back so the WebSocket is handing back the JavaScript. Oh wait, no, that's not what I'm looking at. Where's network? I clicked the wrong thing. Okay, this is what we want. Okay, so I clicked the wrong thing. Genki Doodle, thanks for the follow. Okay, so it looks like when we're wanting to receive something, we send a request for play and give it our stream ID. And it looks like it's returning back. All right, so these are our session description protocol offers, right? So this is an SDP offer, and then we respond back with an SDP answer, and then we get our ICE candidate. So we should be able to implement this, right? So do we have what other things do we have? Do we have like a send only? All right, so that's in C. Do we have a receive only? All right, we don't have a receive only. So, I mean, I guess we can try and we can work on one section at a time. So here's our main. We know in the hello side of things, well, what's it look like for a room? I guess that's the other thing to look at. So if we go to OBS Ninja, okay, so here now we have a room, right? And we can come here and join a room, right? No audio. No audio. Okay, I want to see what goes on here. Start. Okay, so here we have... So first we request to join a room. Then we request seed. What is seed? So seed must be every time we want to send data, right? And then it's sending us back a listing. So this must be all of the participants. Okay, so that's my guess, is it's responding to us with a list of all of the participants in the room. And then that participant is sending us an offer. We respond back to that offer, or we send our own offer. Oops. Yeah, and so we can look through that source code and stuff too. But I mean, I think that this protocol is pretty straightforward, right? So I don't see our own answer though. That's the part that's confusing me here, right? Listing, you know, that seems pretty straightforward. Obviously, we know we get back an offer, right? But we never answer. This is their answer. Okay, so what do we want to work on first? Do we want to try and get it to join the room? All right, let's do it. Okay, so here's the hello. So we are going to need to change that to a join room. Okay. Ah. Can I change these to a different... Does Rust allow me to use both formats? Is that valid? You can use... Okay. What's the error? Expected in format string. Oh, because it's expecting it as a format, right? And we don't actually need to format it, right? We probably do need... The number of things has to match, but it lets you avoid having hash inside of the literal. You just provide more than what it... Gotcha. So if I needed one of these inside, then what I would do is I would put, you know, 2 on the outside or something. Gotcha. Microsoft developer in the house. What's going on? Now, I never know who it is coming from over here. So who is streaming and what were you streaming about? They're probably all watching ads right now. Okay, so I guess we need to change this to a string, right? Okay, so now we've sent our request to join the room. So it looked like the next thing we needed to do was this seed thing. And it looks like I think we need our own. It's generating some ID here, right? All right, so raw string. Okay. Oh, this is a good question though. If we're another participant, I'm guessing the stream ID is unique. Let's try to join again and make sure that our stream ID is something different. I think it's going to be, but Game Men, thanks for the follow. Here we go. Cecil, how's it going? I must have been right. It must have been everybody watching ads. Okay, so let's look at our network. Where's our WebSocket? Yeah, so I'm guessing this is us, right? I think that it probably just generates that one time. Let's look at our WebSocket. We're going to join, turn off our audio. We are discovering all things WebAssembly right now. We're trying to kind of learn how all of the WebAssembly stuff works, as well as right now we're trying to reverse engineer OBS Ninja's signaling protocol so that we can use it to bring in GStreamer, or not GStreamer, bring in OBS Ninja feeds through GStreamer and grab their audio and video directly. Okay, so yep, so this is exactly it. We join the room, then we do a seed request and we pass it our stream ID. Okay. And then it looks like it returns back the listing. And we need to request a play of the other side, right? That's our control room, so we're gonna ignore that. Okay, yep, so we're requesting play on the other side. I'm just gonna put this here, but why they obfuscate the WebRTC.js. Yeah, I'm not sure why they do. Maybe to prevent people from doing exactly what we're doing now. Okay, so here we need to seed, but we're going to use our own ID here. Okay, so at this point, we have now sent the message to join the room, and we have sent the message here, but we also need to request to play this stream, right? Oops. And I think, why do I keep doing that? Why is that not copying? Copy, paste. Is it copying the whole thing? There we go. It was copying the whole message. I was hitting the wrong thing. Okay. So here, now we're going to request to play this. Then in theory, we're going to get candidates and all should be okay. I don't know. We don't want to check that it said hello. I mean, we're going to have to check maybe that it gave us a listing first. But for now, let's comment this out. For here, we're going to comment all of this out. All right. Oh, we're going to need to leave, right? Oh, wait, why is it registering with server? Oh, because this isn't even being used anymore. Okay, so I don't see any new messages here saying that we've joined. So we've clearly done something wrong. All right, let's copy this and let's join again and make sure that we see kind of everything that happens. Wait, where's my WebSocket? Okay, there we go. There's our WebSocket. Oh, there's other messages. We didn't see those before. We've got someone joined, video added to room. Okay, so I guess one way that we could do this is trying to do the room stuff. I think is probably going to be slightly more complicated. Maybe what we should start with is, can we pull video from... Can we pull video? Right, so in this case, let's ignore the joining of the room. We can see that if we were to take this here, let's ignore all of this and let's just do a push, giving it this unique ID, right? Okay, so now we're pushing. Let's see if we can, let's figure out just this part. Okay, so we connect. Well, we want to look at the view side, right? So this is what is going to interest us. So on the view side. Okay. So on the view side, we don't do anything. Sniffhex, thanks for the follow. So on the view side, we don't need the seed. We're just going to pass them a play message with the stream ID. And then from this point, this looks like it is just SDP offers and an SDP answer. And then an ICE candidate. I don't know. I believe that those are specs, so we shouldn't have to do anything. I don't think we need to read the next message here either. Okay, and the sending shouldn't cause an issue, I don't think. Peer disconnected. Why? Okay. So the other thing that's interesting here is why is our pipeline not started, right? Auto video sync, right? Oh, so this is only when we get something that comes in that it creates that. Okay, so we need to figure this out. Okay. So at what point did we get disconnected? Okay, so we need to figure out what is happening here. So we either need to, do I have Wireshark on here? So we only want, what port are you? Oh, no, because this is WebSocket, so we only want, Are you using WSS instead of WS? The browser is showing it using WebSockets over TLS. Oh, wait a second. Oh, wait. And I am also an idiot. We never changed this. We're still sending it to the old signaling server. Oh. Okay, unknown variant UUID, expected ICE or SDP at line column. Okay, so this is when we go to decode something, right? So this is where it's trying to figure out the JSON message that we got, right? And we have this UUID here. So we actually want the description inside of it, right? Like we don't really care about the other things right now. So we need to like wrap this. All right, so this is gonna get kind of interesting. So how does it determine which variant this is? Is this solely based on... Is this solely based on the fields that are in it? Is it that smart? The name of the variant. Right, but as far as the JSON is concerned, is it looking for something that like this? Is that how it's figuring out the variant? Clarkio, yeah, we're figuring out some WebRTC stuff and kind of understanding how things work a little bit better. Right now, what we're doing is trying to reverse engineer OBS Ninja's WebSocket signaling protocol so that we can get GStreamer to read WebRT or OBS Ninja feeds and send them. The default enum tagging for Saturday is key equals variant name. So we would have to have one of these two things as far as this is concerned, which is not what we're going to have, right? Well, wait a second. Because what we're really going to have is like a parent type, right? Well, no, because for ICE, what does ICE look like? ICE is a single candidate instead of multiple candidates. So that's going to be interesting. So here we actually get back an array of candidates, right? Whereas this is assuming that we're getting back a single candidate. So we're going to have to like build our own structures real quick. So let's try to build what this is supposed to look like, right? So let's do type or struct. I don't know. We'll call it request for now. We'll come up with a better name. So we seem to have a UUID, which is a string, right? An optional stream ID. Okay. And then Oh, this is interesting. Okay, because we also for... So we're going to need a rename, right? Okay. So this would be ice type. I don't know. And we're just going to make it a string for now. Okay. And then candidates. Candidates. So this is for ice messages only, right? Okay, so here we're going to have a vec of candidate. Oh, wait, they treat all of their candidates as a string, though. Oh, no. Okay, so we do need a candidate type here, right? So we'll call this an ice candidate. Struct ice candidate. Which is really this, right? Okay. Okay. Oh. Lord MZTE, how's it going? We're reverse engineering some WebRTC stuff today. So we can't find Serday in this scope. I've been working on a tool that lets you turn a bunch of sample JSON into Rust, pipe the output of a tool to it. Oh, cool. Okay, so here we have this. Why are you still complaining? Can't find Serday in this scope. Why not? To make Serday figure out the variant, you can use add Serday tag equals type and name the enum variants with their corresponding type. I'm not sure what where you're going with that yet. You can add Serday tag equals type. Is tag a field in the JSON struct? Is that what you're saying? Wait, why is this still not recognizing Serdays here? Is that in its own scope? No? Oh, I need the... I always forget that. Okay. So you had an enum serializing, so I thought that may be useful to you. Yeah, I just have to kind of understand what that's doing so far. Okay. Okay, so this one is for ice, only for the ones that have ice messages. And then I think that's it. So now I just have to figure out how to decide between which variant these things are, right? because they all have description in them, right? Well, no, I guess there's a type field, right? So the message type is always there, right? So this would be a message type. And then we can create a enum message type. And we have local. Oh crap, no. That's not right either. Because here, this is at the top level, but this is down in description, right? And same here. You're saying the type field should decide the variant. But in this case, that's not the case, right? Because here we have a type at the top and candidates, right? So okay. So here's sort of our options. Let's talk this out real quick and see what we can come up with. So an ICE message has type at the top level. SDP messages have description. So even the type doesn't necessarily work, right? Because we only have type available at the top level when there isn't a description. So what I'm thinking is that maybe what I should do is this. Does it really care? So here and type, and what is SDP? Is SDP okay, so this is the thing we actually want. So in both answer and here have that. Okay, so let's look at this. So we have candidates and then we have description, right? And in this case, description is always some SDP thing, right? Okay, so we have struct SDP, we'll just call it. Okay. What does H mean? Expected type line 77. Oh, because we're just missing this. So I'd make type an enum then though. Oh yeah. So stb type enum. And then our options would be offer or answer, right? Offer, answer. Okay. And this would be SDP type. Okay. What is H? You don't want to rename UUID. Well, I mean, realistically, we don't actually really care about UUID. We're not going to be using that for anything at the moment. Okay, so but it can have extra fields though, right? Okay, so stream ID. Oh, wait. Okay, so we actually don't want to rename all of these, right? Because this should be stream ID, right? Yeah, okay. Okay, I think this is right now. So now we need to go find where we... So this is on ICE candidate. So this is what we are calling. So this is fine. This is our response. Oh crap, wait a second. No. Okay, we're gonna have to keep UUID, right? Because here coming in on this offer, we have this UUID and we have to respond back with it. Okay, so really we have this on ICE candidate. We would have a UUID string, which is going to break some stuff. So have I already started bioengineering at Harvard? I don't think that I'm smart enough for bioengineering. I've actually not attended college. One day. All right, so this is on ICE candidate. Wait, where's values? Where's values populated? So are we not going to have the UUID there? I can clone the string into that closure. Well, so that string won't be here though, right? we don't have that string until we're like processing messages, right? So this is like when we get a message on the WebSocket, this is where we're handling it. And so we have like this handle ICE function and handle SDP function, right? And here's our answer. Set remote description. All right, we got to figure out where we're storing this UUID because we need to signal it on the other side, right? All right, so this is if we get an answer. All right, so here is when we get an offer. We're parsing that SDP string that we saw. Then we're... So then we start up the pipeline. Okay, so this is just us instantiating like an offer type. And then setting the remote description. Not sure what this is doing. Okay, and so this is... Okay, so this is when an answer is created. Oh, right, it's because the pipeline's going to do this. So we don't know yet when it's going to create the answer for us. We're requesting that it create one. Okay, and we're only handling the error case. Okay. And here's where we're passing in the promise that's run. So on ICE candidate, where are you? Or no, where are you called? Let's use this as an example. Okay, this is in the app. So where are these values coming from? And like this. Why? Why is there an array that is holding different types? Okay, so this is interesting though. Because I need to figure out with GStreamer how I'm going to get that UUID, right? Because this callback is set here. And values, I'm guessing, is something that connect passes, right? Yeah, so this is something that on negotiation needed and on. Let's go look up the docs for that. GStreamer WebRTC bin. Okay, so and what's this U data? No description available. Love it. So maybe that's what we can use to store, right? So in theory, Okay, so it looks like we should be able to pass in those arguments. Okay. So it looks like here is where we could pass that along. Okay. So if we go find where handle ice is called, we could use this as an example, right? I mean, we need to fix all of this, but let's just say this is the case. We would be able to pass in the UUID here, and then we would be able to add it to the callback, which would allow us to get it during the callback. All right, let's do it. I don't have too much longer that I'm streaming today. I've got some calls and stuff for work, but let's see what we can do. Okay, so we got to figure out how to break this thing up. So JSON message, really, this is a request. You know what? Where's that request thing at? I don't like that name. Let's call it WebSocket message. Okay. WebSocket message. Okay, so now we have that. I guess we would need to match on well, I guess if candidates is there, right? We're not going to do a match here. So really what we want to do is say if JSON message dot candidates let sum candidates equals this, okay? Then we would need to, what's the best way to loop over these? It's like Rust loops. Because I know I can get an iterator, right? So it'd be candidates.iter. Because it's like a for C in candidates, right? Is that? I'm always afraid I'm going to mess up JavaScript and Go and things like that. So here's this. So we need this. Okay. Wait, what? Nameless 770, thanks for the follow. Expected vect found enums. Wait, what? Oh, because that is not an option, right? I missed that one. Right. So this is really an option. Okay. Okay. Cottonwood, thanks for the follow. That is borrow so you don't move it. I don't know if it's a problem here, and mute if you want to get mutable borrow. Hey Dembski, it's going pretty good. We're just messing around with some WebRTC stuff and seeing whether we can reverse engineer the signaling protocol for OBS Ninja to get GStreamer to send and or join a WebRTC call with it. Okay, so here, handle ICE, we should be able to say JSON message.uuid. Okay. On ICE candidate expected, right, on 221. So here, we're gonna have to do the same thing here and just call it UUID. Okay, so that's that. And then on ICE candidate, we're gonna say UUID. Here's a fun fact: options are iterators for candidate in JSON message iter flatten. Interesting. Trying to make a bunch of standards compliance bits of software talk to each other for the first time. What could possibly? 286. What's going on here? Wait, what is this? Oh, this is like the old. This is the old code, right? So we're just gonna comment that out for now. All right. Expected enum standard result found. Give a typo opt-in instead of option. Uh-oh. Ah. I've only been a professional typer for I don't even know how many years. 15, 16 years. Still can't type basic things. What's funny is I have a new keyboard that'll be here at the end of the week, and I'm going to have to retrain myself to type because it is both a split keyboard and columnar. And I'm thinking about trying to learn Dvorak at the same time. And if I can't type with QWERTY when I've been doing this for I don't know how long, this should be interesting. That's what I figure. It's gonna take me a while to retrain my brain anyway. I might as well just own it. Without visible keycaps. Expected 2 arguments. Wait. Handle ICE. Where's handle ICE? Handle ICE. Okay, and so here we need a UUID. That's going to be a string. And we're just going to make that the last thing here as well. UUID. Okay. 25 heal team. Thanks for the follow. That array order matters. Wait, what? Yeah, I mean, I guess we'd have to just swap them around, right? So maybe I should just do that. Ah. Okay. Wait, now I've got it all mixed up. So this is just the GStreamer GST examples repo. I can still touch typing QWERTY, but it does take some more concentration to do. So, okay, so you're a Dvorak user. Yeah, like I've noticed, like as I've gotten older, like RSI has become harder and harder on me. So I figure if I'm gonna put in the effort, I might as well try. All right, what did I mess up here? Oh, because candidate is an ICE candidate, right? And what we really want here is candidate and candidate dot, right? Value moved here in previous iteration of the loop. Okay, so we need to clone this. There we go. Okay, so that's one message, right? So we've handled ICE, but we also need to do the same thing for handle SDP, right? So here, this is going to be a techie thought. Thanks for the follow. Okay, so here we're going to also pass in UUID, which is going to be a string. And are we putting any of that information here as well? Yes. So here's our promise, but we're going to do the same thing here. We're gonna pass UUID. I'm going to pass it here too because I think we need it for the answer as well. Okay, so here we need to do a else if let some description, right, equal JSON message dot description. And the description is optional, right? Option. Okay. Used to have bad RSI in my gaming days. Now it's kind of low level, but still there. Yeah, so the one I have coming is actually like really, really cool. ZSA.io Moonlander. So yeah, this thing's like really, really cool. Does have like a... Where's the thing that shows you how it bends? But yeah, so you can see kind of how you can adjust. And then it's completely open source, has programmable layers. So it should be... Okay, so now we need to handle our SDP, right? Okay, okay, so here we need to pass in UUID, right? JSON message dot UUID dot clone. Okay. I really want that keyboard now too. Yeah, you should check it out. It's expensive, but it looks really awesome. GStreamer only lets you have 10 parameters and a callback. It's way less interesting than I thought it'd be. So I actually, my current keyboards are Cherry MX Clears, and that's what I've had for quite some time now. But what I ordered in the Moonlander is blues. I've always wanted to try Cherry MX Blues, so I decided that I would. And then, you know, worst case, I hate it, and then I just steal the clears out of my current keyboards. Okay, 479. We need a reference. And then same thing in 498. Okay. Get rid of the crank up the noise suppression. Yeah, I mean, I guess my current microphone probably picks up my typing already. I'm a pretty heavy typer. It's better with the dynamic mic. But I mean, I also have a noise gate, like a hardware noise gate. Like, you'd actually be really surprised. I have, like, right next to me over here is a tower that's almost as tall as my desk that has 16 fans in it. And you really don't hear it on stream. And that's mostly the noise gate. Oh, yeah, 289. So this should really be JSON message.type and JSON message description.stp, right? Oh, and this is, oh crap, no. Description.type and description.stp, right? Is a 900D, I think it is. Yeah. The keyboard picks up a little bit, but sounds fine, and no, wouldn't have realized there were 16 fans there. Yeah. It's quite crazy. Yeah, I don't mind the sound of typing on people's streams when I'm on their streams, as long as it's like not like so overpowering. Like, if it's like a subtle thing that's almost like ASMR underneath, you know, they're speaking, then I don't really have a problem with it. Oh. Okay, so here, you know what? I'm gonna go back up to where STB type is. And for now, I'm just gonna make this a string. We're just forwarding stuff for now. I just want to see this work. Okay. I have no clue if any of this is going to... Oh, wait. No, it's not. Because JSON message... Because in here, we're actually responding back with the different message types. We're not going to have time to implement this. I was thinking it was going to respond back with the same things, like it's a standard, but it doesn't, right? It responds back with this. So we need to do the same thing. Well, no, because we should be able to just convert this to a WebSocket message, right? And this would be so UUID would equal... Wait, how do we get it out of here? All right, so the offer created is going to be the harder one. Because what is the UUID? The UUID, I think, is our UUID. Yeah, I kind of feel like we might want to start with like a bare bones thing here. Gutting this is becoming quite complex. So on offer created looks like, and on answer created. Answer. What type is this? A WebRTC session description. Okay, so, but we still don't have the UUID, right? So we need to figure out how to pull the UUID out of the WebRTC bin, I think. Like, do we have the ability to just store things on the WebRTC bin? Because the bin will be unique. Okay, so on create answer, we do have that. Wait, where's our on answer? On answer. Oh. So this is the create answer. That's the promise. Okay, so we're passing it into create answer, so and this is the reply. Okay, so really I think what we need to do is pass the UUID here, right? Because at this point, this is where we know the UUID for sure, right? Like we could just clone the UUID here, and then it would be called as part of the callback. Okay, so I guess we need to rethink that a little bit. Which would mean we don't we don't really need to pass it here, right? I'm gonna reorder these. So all right. So then on. So now here we can just say UUID string, right? Now we have our UUID. Okay, so now we have to worry about like our response messages. Okay, so here we're going to have a WebSocket message, which is going to have a description, which is an SDP, which is all of these things, or has all of these things. Okay. It's going to yell about a bunch of stuff missing. Crap. Stream ID. We have to figure that out yet too. See, bro, how's it going? So the enum standard option found struct. Oh, right. So this is actually some SDP. Dennis Bot, thanks for the follow. Oh. Demsky, see, bro, ask me how many times that I type struct field names using Go's capitalization all of the time. Yeah, like literally all of the time. Like right here. Wait, I actually might have named it that way on the field too. WebSocket message. Wait. Did I name it that way too? I did. I did name it that way. Okay. So we found another place that we don't have it, right? But I think we can do the same thing here, right? On offer created, and then we just have to find everywhere. On offer created. We should be able to just pass in UUID. All right, so this UUID is not found in this scope. Where is on negotiation needed determined? Crap. Yeah, so we're gonna have this issue too, because this like on negotiation needed is on the app level. Well, no. Strauss Games, thanks for the follow. So what I think we're gonna need to do is, just because of the way this is all organized, this might be easier to step through. Because I keep forgetting the app is not, this is not managing multiple connections. In this particular case, app just represents us, right? So which incoming video streams do we have and which are single outgoing stream? So realistically, all of this stuff can be redone, right? So on the app itself, where's our app? App inner. So in all of this, we should be able to just store our ID here, right? This is really where it should live. And I think most places have access to self to be able to get the UUID. So I think we need to find everywhere where we're doing all of that UUID logic. Right, because everywhere here we have access to app. Because even like on this on ice candidate, right, we still have self. So let's wait. Yeah, that still has it. Okay. So we're gonna get rid of all of this. Yeah, I should do that too. I have a bad habit of Well, I think this is valid though, right? Because that's the proper capitalization for it. Is that true? All right, so this needs to stay. That needs to go. Okay. 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 Missing UUID 182. And we're just gonna steal one. Don't care. You look good. I gotta stop doing that. I keep selecting copy message instead of copy. Okay. Okay. So, oh, right. It would be self.uuid, right? Or not. All right, so there's one down. Well, okay, so we need to redo all of this, right? So I'm gonna change this, right? All right, so this is an answer, right? So really everything else stays the same except this part, right? So there's our session description protocol answer. Okay, and so now we need to handle our ICE candidates, I think. Right, so there's our on ICE candidate. Here's the offer, here's the answer. Okay, yeah, so all right, let's copy this, go back here and take a look. Okay, so oh, we don't have a stream ID yet. So we're gonna have to figure that out. But so for here we have the candidate, right? So description is going to be none. Candidates is going to be a vec of candidate, right? Nope, it's ICE candidate, right? And then we just have candidate. I guess we don't really need that, right? Candidate and STP. Yeah, okay. So in theory, this should be what we need aside from... Uh-oh. Oh, right, because it's an option. So some. Oh, because this is mline index. Okay. So now we have to figure out what to do about the stream ID. I think I'm going to just make one up again. Right? Like we did the UUID. I guess we still have to figure out what the difference between this... Oh, crap. I'm wrong. So I messed this up. Right. I don't know. We'll just... I mean, I suppose we can just make one up here, right? And just say A, right? To string. Okay, so the stream ID is us individually, right? So here we're sending a request and this is pushing. So this is telling it who we are, right? So we still need to do... Did we do that? Where is it? There we go. Okay. All right. So that's us. This is us requesting to play. Maybe that's the better one to look at right now. So it responds back with a UUID. And then from that point forward, we're using that UUID. Right? Okay, so we need to look at the very first request that comes back. So this should be handle... I guess we could just use a bogus thing for now. So we need handle WebSocket message, right? And so once we get back this JSON message, we need to do a self UUID equals JSON message UUID. This is like super hacky, but I gotta jump off here in a minute and I want to see whether this works. Cannot assign. Deref mute is required to modify through a dereference but is not implemented. I have no idea what that means. Cannot borrow is mutable. Wait, where? On 645. All right, so why is app? All right, so mute app. All right. Self is read only. Well, that's not good. How are we going to get around that? If you wrap the field in a ref cell mutex, you can use interior mutability. All right. Mutex. Is there an impl app inner yet? Okay, so if we did a impl app inner set UID string then we should be able to do a oops. And we should be able to do a self.uuid.lock dot wait. I don't know if it has to be a mutex. Ref cell isn't thread safe. Right. Now I'm trying to remember there's a, I think I have to do the deref thing. Or is it smart enough to do it? No. Oh crap. Are they not found in, okay. Alright, I'm gonna fix all, wait. Ah. Unwrap. I will never remember that you also, that a lock actually returns back a result. Every time. Lock. Unwrap. We're gonna fix all this ugliness, but I gotta go. And I want to see if this works. It probably is not going to work, but it would be cool if it did. Lock. Unwrap. Clone. Oh, wait. No, this is, we need, set UUID. I have little hope that this is going to actually work, but what? So that's just a random UUID for now. It could really be an empty string. So, I mean, it did more than I thought it was going to do. Invalid type string local expected a sequence. So where were we returning back local? Invalid type string local. Oh, wait a second. Yeah, so where we send back the candidates, right? We need type. Wait a second. We don't even have type there. So this should be, right? Okay, so on this one, we need message type, and this is going to be some local to string. Oh, wait a second. Option. Okay. 387. 387. Okay, so in this one, we need message type to be none. Okay. And then on 440, wait, 392. Wait, why can that infer type? Cannot infer type for type parameter t declared on the enum option. Huh? Ah. All right, so I want to okay, so we did do it there. All right, what happens? We didn't disconnect. But I mean, we should be getting this though, right? Because we're still pushing it. So we're gonna have to probably debug the WebSocket or something. Because we got an offer, we're sending back an answer, right? And so if we view our WebSocket here for our view, we did play. This is our offer. We send back an answer, but it doesn't look like we got any candidates, right? And so my guess is that has something to do with the UUID stuff or something, right? Oh, wait a second. See here, we get this session. So here's the stream ID, but here's the session. I wonder if we're sending that back, right? We're not. So we need to look at their offer and save the session too. So that's probably our issue, right? Is that if we look at app inner, we probably need, you know, something like this for set session, 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 and then we need to do the same thing, session, and then we need to handle SDP, right? Missing session. Well, I know that. What line? 195. 195. All right, so we're going to do the same thing here. Session, you're going to be empty. Okay. And then on handle SDP, right? So here's our offer. Oh, wait, we need our web socket message. Wait, where's our type for that? All right, so here in our message, we also have, oh no, it's under description, right? Yeah, it's under description. Okay, description is an SDP. Okay, what is it called? Session string. Okay. Handle SDP. Okay, so here's this function on an offer. Right, okay, so when we get the offer, hold on a second. No, we need to go back to where this is called from. This is the point of interest, right? So here is where we wanted to do a self.set session equal to description.session, right? Okay. So now our only issue is we need to figure out how we are responding back to, right? What's that called? Type. All right. So this is when we're handling the message. Here's where we're creating one. So this is where we're sending the offer to the peer. We're not so concerned about that. We need when we're sending back the answer. Sending answer to peer. Okay, so here's what we want. So we want session equal to self.session. Uh, 401, we're missing session. Okay. Oh, 455. Oh, right, because we really need a lock dot unwrap. All right. And then we need it in the other place too. Wait. Isn't it? Oh, because we want to clone the value held within and not the mutex guard itself. Right. Okay. Dot lock dot unwrap dot clone. Okay. All right, this is the last attempt, and then I gotta go. Help, you might. Oh, on line 131. 131. Session. Okay. Missing field session. Missing field session. I don't know which part of this that is, though. Do we send it in the offer? We do. Like, should I just make one up? Ah, okay. All right. I got no time left. We gotta raid somebody. Oh, it's on the deserialization. Okay, okay. So we'll
less than maybe a little more.
We'll check that out tomorrow. Who's streaming? We got the Milkman. We got Anthony Writes Code. We got Bald Bearded Builder. Melky, I'm game. Let's get it. All right, everybody. Thanks for hanging out. Appreciate everybody hanging out around, especially when we do like these weird, crazy things. Casada, thanks for the follow. I didn't catch it earlier, but especially like when we're doing some of these things that just seem to take forever with no like forward momentum. But it's kind of fun to learn and experiment. I will be back tomorrow around 12:30 Eastern time. Catch you all then. Thanks, everybody.